Okay, Year 11s, I'm just going to go through a past paper from 2013, which is a while ago, but because we're changing the type of assessment, this is more like what you you could expect on Friday. Um, Alright, so without further ado, let's get into these questions. So Sam is comparing the growth rates of two different types of cucumbers. The two types are American and European. He plants 20 of each type into his garden and measures their length at the start of each week over an 8-week period. He then calculates the average lengths for each variety type. The average length of the American cucumbers is shown on the graph below. Okay. What was the average length of the American cucumbers when Sam started measuring? Well, starting the measuring, that's going to be at time 0, so that is where we intercept the y-axis. So each one of these divisions 2, 4, 6, 8. So 8 centimeters. And how can you tell this from the graph? It's where the line intersects the y-axis. Okay, the equation for the average length of the European cucumbers is L equals 3t plus 6. So if we had y equals mx plus c underneath, the gradient of our line is going to be 3. X is replaced with t, y is replaced with L, and our y-intercept is going to be 6. So we'll draw this equation on here. I'll write it again up here. So we've got length equals 3t plus 6. So this number here is our gradient. So I always make it into a fraction. So 3 rise for every 1 run. I might just do this with a different pen, so we'll go green. So it intercepts at 6, and then one way of drawing your graph is to go over 1, up 3. So, well, this is tricky to do on here because you've got to think 1, 2, 3. So it's going to be more like there. So actually, I think the best solution for this is to work out what it would be at 7 weeks, for example. So to do that, we're going to go t equals 7 and put that into our equation. So that'll give us a length of 3 times 7. So I'm just replacing t with a 7 plus 6. So 3 times 7 is 21 plus 6 is 27. So that will, there's 26, so that's going to get us a mark about there. And we'll just draw between there and that point. There we go. Doesn't have to be super accurate, but yeah, just watch what your axis is going up in. We're going up in 2s here, so a rise of 3, a run of 2 wasn't very helpful. We could have done 6 for every 2 we went over. That would have been easy to count because we just count up 3 over 2 to get a mark here. Anyway, let's carry on. Question 3. In Monrovia, you pay no tax on the first $10,000 you earn. For any income over $10,000, you pay tax at the rate of 25 cents on the dollar. This is represented by the equation 0.25 s minus 10,000. So this is kind of weird because it's different from our y equals mx plus c because it's got this bracket. But what we can do is just expand the bracket, and then we will get something more familiar. So when you expand a bracket, you want to take this number and multiply it by both of the numbers inside. So we're going to get t equals 0.25 s minus 2,500. Yeah, so that might be more familiar in that form. So this is still a line equation, but x is replaced with s and y is replaced with t. Our gradient is 0.25. So another way of thinking that is you could also have it as a fraction, so it could be a quarter s plus minus 2,500. That's another way of writing the same. So these are all equation 1, same equation, just written differently. Alright, last year Anna earned $75,000 before tax. How much tax did Anna pay last year? So S is the total yearly salary. So to work this out, we just plop it in the formula. So 1/4 of 75,000 minus 2,500. Putting that in the calculator. Minus 2,500. 16,250 dollars in tax. Alright. Question 4. A swimming pool lost some volume in the earthquake. It has been refilled with water from a hose. The depth of the water in the pool was originally 90 centimeters and is increasing at a rate of 4 centimeters per hour. So whenever you see the word per, you've got to think that's my rate. And in linear algebra, rate it's basically just your gradient on your line. They're just interchangeable words, really. And this original 90 centimeters, that's likely to be our starting point. That's where it started. It was originally 90 centimeters. So let D be the depth of water and T be the time in hours. So if we're following a y equals mx plus c, D and T, there are new variables instead of y and x. So D, that's going to be replacing y, and T, that's going to be replacing x. Our y-intercept is going to be 90 centimeters, and our rate or gradient is going to be 4. So that's it. 4t plus 90. Alright. Each spring the Godwits return to Christchurch to breed. One Godwit has a transmit attached to it, and its distance from Christchurch is monitored for the last 8 hours of its flight. So I think a Godwit is a bird. Alright. The Godwit changed speed 3 hours after the monitoring was started. Did the bird speed up or slow down at this point? Well, speed, like a higher speed is a steeper gradient. So the gradient in the first section is not as steep as the gradient in the second section. So you could say the bird sped up. And that's because it's a steeper gradient. Steeper means faster speed. What speed was the bird traveling during the final 5 hours of the flight? Okay, well, you can get that basically directly from drawing a triangle onto the graph. So on the rise, we have dropped from 350 all the way to 0, so that's a negative 350 rise. And in terms of time, we've got 8 minus 3, so there's 5 hours down there. So if it travelled 350 rise over run over 350 kilometers, was it? Or meters? Yeah, kilometers over 5 hours. I'll actually just drop that on the other side. That's going to be 70 kilometers per hour. Alright. Bart steals Homer's clothes while Homer is having a shower. Homer gets out of the shower and chases Bart. Bart is 20 meters from the shower when Homer starts chasing him. Okay. Bart runs at a constant speed of 6 meters per second. So speed is a rate, which is our gradient. So we'll use that. And also we know that Bart starts at 20, so he's got that on Homer. Whereas Homer is going to start at 0. So we might just use blue for Homer. So that's where they both start. 6 ms minus 1 it means 6 meters per second. So 6 meters per 1 second. So you can think this is your rise, this is your run. So if we wanted to do it every 5 seconds, we can multiply the top and bottom by 5. So we're going to get 30 meters for every 5 seconds, multiplied by 5. Top and bottom. So let's draw on Bart's points. So we're going over 5, up 30. So plus 10, 20, 30. Get there. 1, 2, 3 over 5. Got this mark here. Up 3, 2, 1, 2, 3 over 5. Alright, now let's do Homer. So Homer runs at a speed of 8 meters per 1 second. So, well, that's what 8 ms minus 1 means. This is a fancy way of writing the same thing. But if we wanted to multiply that by 5 top and bottom, we get 40 meters for every 5 seconds. So our first mark, Homer's going to be here, up 40 over 5, and then up 40 over 5. So Homer and Bart intersect at that point 10 seconds in. And then after that, Homer's probably caught him, so it doesn't matter, but it would carry on up like that. So I'll just connect some points through. Not great. Maybe I'll forget about that for now. You get the idea. Alright. Calculate how far Homer has run when he catches Bart. Well, off the graph we can see that they both cross at that point 80 meters. And that's after 10 seconds. So another way of doing this would be to well, set your two equations. Well, you could have had two equations. So Bart's equation would have been so Bart his distance is equal to 6 meters per second times the time plus where he starts, which is 20 meters ahead. So 6t plus 20, and then Homer would be just d equals 8t because he's plus 0, he starts at 0. So to calculate when they meet, that'll be the point where the distance is equal. So d, that'll be where Homer equals Bart. So you can put the two equations equal to each other. 6t plus 20 equals 8t. And if I take that 6t the other side, we're going to get 20 equals 8t minus 6t. 20 equals 2t. T equals 10. And then I take that 10, put it into one of my formulas. D equals 6 times 10 plus 20. So 60 plus 20 equals 80 meters. That's 10 seconds. Alright, next one. Question 7. A bucket is filled with water. Unfortunately, it has a hole in it, and water leaks at a constant rate. 10 minutes after it was filled, the bucket contained 8 litres of water. 30 minutes after it was filled, the bucket contained 5 litres of water. So this is, if we made a little table of what's going on, there's a time, and then there's the amount of water. Oh, we should probably do volume actually. So at 0, we don't know what the volume was, it hasn't told us yet. At time 10 minutes, there was 8 litres of water in the bucket. At 30 minutes, there was 5 litres of water in the bucket. Okay, so we got those 2 points. Let time be the time interval since the bucket was filled, and V be the volume of water in the bucket. By graphing the following information above, or otherwise write an equation that shows the relationship of V between T. Okay, so what we have is just 2 pieces of information. And that's all you need for a line, is 2 points on a line, and then you can draw the line between them. So at 10 liters, 10 minutes, we had 8 liters, so we'll get a mark there. And at 30 minutes, we have 5 liters, so we get another mark here. And if we draw a line between them and extend it out to the y-axis, we are going to get this intercepting at 9.5. So we can use that to write our equation. Also, we can use these 2 points to find our gradient. So what are we going down? We're going down 3 liters, and that takes 20 minutes. So our gradient is going to be rise over run, 3 liters over 20 minutes. Yeah. Okay, so that's our gradient. Our y-intercept is at 9.5. So we're just going to put in I'll just write y equals mx plus c again. So instead of y on the y-axis, we have volume on the y-axis, and on the x-axis we have time. So we just replace those letters with those letters, and our y-intercept we found to be 9.5 by just extending that line back between the 2 points, and our gradient we found to be 3 over 20. Yeah. So 3 over 20 times the time plus 9.5 will give us our volume in litres. Okay, that's that question done. Let's do question 8. Right, 4 sandwiches and 2 fruit juices cost $25. So this is actually a simultaneous equations question. So 4 times, I'll just use A and B. 4A plus 2B equals 25. That's from equation 1. And then 3A plus 1B, or just B, equals 1650. Oh, I suppose I was supposed to write them in underneath. Let's just do that. I'll just drag them under. Okay, so we have our equation 1 and equation 2. Solve the equations in part A to find the cost of the sandwiches and fruit. So generally you guys have had 2 line equations which look like maybe this. So to find where they intersect, you could just set them equal to each other because they're already set equal to y. But as it is currently, nothing's set up equal to y. So what we're going to do, I'm going to take equation 2 and I'm going to rearrange it for b. So rearrange. So an easy way to rearrange this is to take this 3a and subtract it to the other side. So we're going to get b equals 1650 minus 3a. And the reason I did that is because it's going to make it easy to substitute into equation 1. So what I'm going to do is I'm going to take my equation for b in equation 2, and I'm going to substitute it into equation 1 where there's a b there. So b is equal to 1650 minus 3a, so I'm going to take that and drop it in there, and that's called substitution. So that's going to look like 4a, so 2 into 1. So this little arrow just means into. And that just tells the marker what you're doing. So 4a plus 2 times 1650 minus 3a equals 25. So basically I've taken that 1650 and I've dropped it. Instead of there being a b there, there's now 1650 minus 3a. Okay, so now we've eliminated our variable b, so we can solve for a by doing our algebra. So first step, we need to expand our bracket. Well, I changed pen color. 1650 times 2 is going to be 33. 2 times negative 3a is 6a, equals 25. So I only expanded the bracket then. 4a minus 6a is negative 2a. This 33, I'm going to drop it on the other side. So we're going to get 25 minus 33. So negative 2a equals negative 8. And so divide by negative 2 both sides, we're going to get a equals 4. We're not quite done. We need to figure out b. So up here we have an equation for b, provided we've got a's, and it's nice and easy for us to work that out now. So 1650 minus 3 times 4, because we just worked out a was 4. So b equals $4.50. Alright, that's that. How many more questions are there? Last question. Homer, Barney and Lenny all make New Year's resolutions to lose some weight. If T is the time in months since New Year and W is the weight in kilograms, then Homer's weight is given W equals 160 minus 6T, and Barney's is 105 minus T. Unfortunately, Lenny fails to stick to the resolution. He weighs 90 kgs at the start of the year and has his weight increases at a constant rate of $3 per 3 kgs per month. Okay, so I'm just going to rearrange these because at the moment they've got the y-intercept happening first, which is common when you've got a negative gradient. You might see questions written like this, but really this is W equals negative 6T plus 160. So it starts at 160 and it's going down 6 for every 1 it goes across. So what I'm going to do, I'm going to change this negative 6 to a negative 60 over 10. And the reason I did that is because I can get another point on there quite easily. So when t equals 10, we would have gone down 60. So we're going to get a new mark over here at 110. Barney's weight, I'll do that in another pen, so I'll do that in black. That's like you've got negative t plus 105. So he starts at 105, so that's halfway between this grid line. That's 110. Going down 1, so negative t gradient is a negative 1 over 1. So if we want to extend that to 10, we're going down 10 for every 10 it goes across. So after 10 months, Barney will have gone down to 95. So that is just below Homer there. Lenny, on the other hand, starts at 90 kgs, so his weight is a plus 90, so that's where he starts. His rate of increase is 3 for every month. So you could go 3 over 1, or 30 over 10. Might be more useful. So if he starts at 90, he's going to go up 30 kgs over 10 months. So up to 120. Alright, I'm trying to draw these lines in as accurately as I can. Alright, good enough. Alright, next one, black line. Barney. There we go. And Homer. Starting way up here. Ooh, that's not great. Try one more time. I've lost the black line now. Oh, dear. Okay, this isn't playing ball, so we'll just leave it there. Free-handed him. Good enough. During the year, there's a period where Barney's weight is the least of the three. What time period is this? So that will be between these two intersection points. So we can find that by setting green equal to black to find our first point. So 3t, this is Lenny's one, plus 90 is equal to Barney's weight, negative t plus 105 from above. So I did change Lenny's to simplify it for the algebra. So this is Lenny equals Barney. if we rearrange this, we're going to put the 90 on that on the other side and the negative t on the other side. We're going to get 4t equals 195. So t equals 195 divided by 4. Which equals 195 divided by 4 equals 48. I know what I've done wrong. It's not. It's taking away 90, so this will actually be 15. So 15 divided by 4 is 3.75 months. And then over here, we've got blue line intersects black line. So it's going to be 6t plus negative 6t plus 160 equal, so this is the Homer equation, is equal to the Barney, negative t plus 105. So if we collect our, let's go t's on the right, so that we get positive. So 160 minus 105 is equal to negative t plus 6t. So 5t is equal to 55t. So t equals 11. So 11 months. So the time period, the period is 3.75 to 11. Okay, that's the end of the test. So I'll leave it there.